this question was a request, I really do mean it when I say read this question 5 to 100 times. Actually, 50 to 100 times. I don't like this question for so many reasons, but it is about time that I cover a question involving this particular distribution. So, not a lot to set up really. We're given that the probability that one or more accident happens, I believe in a month, is one or more accidents occur in 1 month. I believe it's 0.6. Accidents occurring in different months are independent. You do need independence for what we're going to do. So that's important. Okay, make sure that when a question tells you that specific events are independent, that you utilize that. If you don't, you're probably doing it wrong. And we're after this annoying thing. We want to know the probability that there are at least 4 months with no accidents before the 4th month with at least 1 accident. So why do they have to use all the fours for one? That alone is annoying. I mean, just reading this statement is annoying. Just read this 5 to 100 times, literally. I'm not even kidding. I definitely got this question wrong the very first time I looked at it. Since then, kind of funny the way math works. The more exposure you get, sort of things just somehow become easier. I have no idea why that is, but it's weird. That's the way it is. All right, I need to define a random variable. Okay, so I'm gonna let n be the number of months with no accidents before the 4th month with at least 1 accident. So this is going to be the number of months with no accidents until the 4th month with at least 1. At least 1 accident. So I already don't like this random variable because for one, it's so long. Okay, so it's already annoying. Let's just think about this for a second. I'm going to sort of rephrase this in general. What is this saying? So we're thinking of, basically what I'm thinking of is that I want to think about, well, independence. What distributions involve independent sort of events? Well, you have binomial, you have negative binomial, and you have geometric. Does this fall into the geometric case? No, because that would be the number of failures till the first success or number of trials till first success. But how many successes do I want? I want 4. I actually want 4 successes. So it's not going to be binomial either. And actually, it could be binomial. I refer you to, again, to GU's study manual. Every negative binomial question can be completed, can be answered using a binomial distribution. It's an interesting idea there, so I recommend taking a look at that. I'm going to answer this using a negative binomial. I don't think this is the way SOA answers it either, but it doesn't matter. This is what makes sense to me. So, number of months with no accidents until the 4th month with at least 1 accident. So, this can be sort of, in general, thought of as the following. This is the same thing as saying the number of failures until or before for 4th success. Let's say that before 4th success. So before 4th success. And I'm just writing it this way because this is one of the ways to write a negative binomial random variable. So that's what I'm thinking here. So we need the probability of success. Here, success is 1 or more accidents, right? So that is 0.6. So I'm thinking of success as 1 or more accidents. Okay. So we know that. So we know that the probability of success is 0.6. So what is it that I'm actually looking for then? Remember, I want the probability is at least 4 months with no accidents. Okay, so there needs to be at least 4 failures before the 4th success. So n is the number of failures. This is my n number of failures before the 4th success. So we want here to find the probability that n, the number of failures before the 4th success, is at least 4. Is at least 4. Now, of course, I'm not going to compute it this way because it sucks, so I'll compute the complement. This is equal to 1 minus the probability that n is strictly less than 4, in other words, less than or equal to 3. So this is what we need to find. Now we need to find this business. Obviously I need some more room, so let's do that. So let's write down, we're actually ready now to write down our distribution. So we're going to use negative binomial, and something you need to know regarding negative binomial is there are 2 sort of common ways to define a negative binomial random variable, and that is either the number of successes or the number of trials until the kth success, or the number of failures until the kth success. So given what I've said here, we're looking at failures. Okay, so I don't want to write it all down again, but hopefully you did. Okay, so for my random variable here, I'm going to write it this way. We're thinking of it as the number of failures until 4th success. Okay, and I already defined what a failure is and what a success is. So, what is the probability mass function? Okay, so n is negative binomial. If you want, you can say this. N is negative binomial with p, probability of success, 0.6. All right, so the probability mass function of n, this is a tricky one to remember. If I'm looking for failures, the way that you need to set this up actually, well, what is k? First of all, k is equal to 4. I need k. This is going to be n plus k, which is 4, minus 1. N plus 4 minus n plus k minus 1, choose k minus 1. Choose k minus 1 times the probability of success. Probability of success is 0.6. And I need to raise that to the k power. K is 4. And then times 0.4 raised to the actually the n power, So it's kind of weird here. Our sort of we're actually fixing the successes, and we're saying how many failures do we need. So this is pretty much the opposite of what you would do if you did, say, the binomial distribution, right? Binomial distribution, you're sort of fixing the number of trials, and you're letting the number of successes vary. All right, and then what we're looking for is this. So I want to know what is the probability that n is greater than or equal to 4. Again, just to sort of rephrase this in the context, we're looking for the number of, we want the number of months, we want there to be at least 4 months with no accidents before the 4th month in which there were 1 or more accidents. Such a nightmare of a sentence. I mean, could that be any more confusing? In my opinion, it's extremely confusing. Alright, so this is equal to 1 minus the probability that n is less than or equal to 3. So let's write this out. Not too bad from here, actually. I'm going to give myself just a little room. Hopefully I can fit it all in the remaining portion. Okay, so what we're going to have here is the following. This is equal to 1 minus, okay, I'm going to put parentheses here. We need to start at n equals 0, so this is going to be, when I plug in 0 here, this is going to be 3 choose 3. Okay, so 3 choose 3 is 1, and this is going to be 0.6 to the 4, plus, and this is to the 0 power, so gone, right? Now plug in n equals 1. That's going to be 4 choose 3, if n is 1. 4 choose 3 is 4 times 0.6 to the 4th. It's always going to be 0.6 to the 4th. And then 0.4 to the 1. 0.4 to the 1. Okay, so we have that plus. Now I'm going to let n equal 2. If n is 2, then it looks like I get 5 choose 3. 5 choose 3 is 10. And now I have 0.6 to the 4, 0.4 squared. Already running out of room, quite annoying. Let's see if I can fit it though. Now I need to let n be 3. So final one, let n be 3. When n is 3, I'm going to get 6, choose 3, which is 20. So plus 20 times 0.6 to the 4 times 0.4 to the 3. Every time I make a video, the dogs love to bark. So typical. Thank you guys. Appreciate that a lot. So what I have here now is the following. Let's just simplify this. Just write it out. So hopefully you're seeing, let me just write out what I just did here. This was probability n is 0. This was probability n is 1, right? This is probability n is 2. And probability n is 3. So I'm confident you can plug all that stuff in, right? That's, I don't think, the tricky part. Now, what I'm getting here, just simplify this. I mean, this is calculator work, right? This is just calculator work, and what I'm getting here is approximately, so this is approximately 0.29. And I mean, you get some other decimals here, but it rounds to the nearest hundredth. I get 0.29. So that's our answer. Again, I recommend taking a look at Goose Study Manual. He goes over how to answer questions like this, and you can always use, a binomial distribution. So something to think about. But obviously, I recommend learning the negative binomial distribution as well. Tell me what you think, and comment on the video. Thank you.